Hello everyone, I'm James and welcome to episode 6 of the OpenGL tutorial series. Today we're going to be making more complex meshes and we'll discuss the topic of indices.
This is our triangle right now. How can we build more complex meshes out of triangles? Let's start with a simple quad. It's very simple. All we have to do is join two right-angled triangles together. There we go. Let us take a look at the list of vertices. There are 6 vertices, 3 for each triangle. However, you might have realized that some of the vertices are duplicated. In fact, quads only have 4 vertices, however we have 6 vertices with our current system. What can we do to avoid these duplicates? This is where indices come in. Instead of specifying the triangles with vertices directly, we'll specify the triangles with indices that point to vertices. This is how it will work. We'll have another list, this time a list of integers representing the indices. We'll remove the duplicate vertices from the vertex list and we'll use the indices to build the triangle instead. For more complex meshes, this will reduce the amount of memory significantly. It also reduces the possibility of making mistakes when we need to specify the same vertex.
Let's change our system to use indices and then after that we'll create a cube.
To get indices to work, we need to add another buffer to our mesh, which is called the index buffer. So we'll first add a field that will store the index buffer's ID. We'll change the vertex count field to index count because this will store the number of indices instead. Next, we'll make the constructor take in another vector, this time of unsigned integers. In the definition of the mesh constructor, make sure you add the new parameter. Initialize index count to indices.size. Now we'll create the index buffer, right after we create the vertex buffer. Next we'll bind the buffer. This time we want to use this buffer as an index buffer. So for the target, pass in GL element array buffer. For the second parameter, just pass the IBO ID. Setting the data of the index buffer is similar to setting the data of the vertex buffer. For the first parameter, which is the target, we'll once again pass GL element array buffer. For the second parameter, which is in bytes, we'll pass the size of the indices vector multiplied by the size of GL uint. For the third parameter, which is the data, we'll pass indices.data. We won't be modifying the indices, so for the last parameter, we can pass GL static draw. Let's not forget to delete the buffer in the destructor. Finally, in the draw method, we are going to call a different function. Instead of GL draw arrays, we'll call GL draw elements. For the mode, we'll pass triangles again. For the count, we'll pass mindex count. The next parameter specifies what type of indices we are using. In our case, unsigned integers, so we'll pass GL unsigned int. The last parameter is a pointer to the indices. To be honest, I don't know why it takes this parameter. We don't really care about this parameter, so we'll pass null pointer. In the main file, let us specify the indices. Since we only have 3 vertices, we can simply put all the indices in ascending order. All is left to do is to pass the indices to the mesh constructor.
If we run right now, there you go, we get the same result. Now let's do something a bit more interesting. We'll add another vertex. We'll make this vertex at -1x and +1y. We'll set this vertex to be at +1 and +1 for both x and y. For the indices, I'll specify 0, 1, 2, and then I'll specify the bottom one, so 0, the top right one, so 3, and the bottom right one, so that would be 2. So 0, 3, 2. And now if we run, well, I messed up. Yeah, it should be 0, 1, 3, not 0, 1, 2. There you go. We have a square rotating in 3D. Now let's make a cube. I created a static function that creates a cube. In the mesh.cpp, here is the code for it. It will be available on GitHub later. So I've defined the 8 vertices that make up a cube, and here I've defined all the indices that specify the triangles. Every line specifies one triangle. It's important that each of these indices are in clockwise order. You can do it in anti-clockwise order, but if you do anti-clockwise, make sure you stick to anti-clockwise. I prefer clockwise. In the main file, I commented out the code we had that made the quad. I created a cube and stored it in a shared pointer, and instead I rendered the cube here with cube.draw. Now if we run, this is what we get. It looks a bit of a mess, doesn't it? How can we solve that?
So why is this happening? This is happening because we have no ordering. We don't know if a triangle should be in front or behind another triangle. What can we do to fix this? This is where the depth buffer comes in. The depth buffer is very similar to the color buffer. It stores pixels. However, instead of storing color information for every pixel, it stores depth information. The way it works is we clear the depth buffer every frame and we set it to a very large depth value. Then, when we come to write to the color buffer, instead of writing directly to the color buffer, we check what there is in the depth buffer. If the depth value we are currently writing is smaller, if the depth value that we are going to write is smaller than the depth value in the depth buffer, then we write the depth to the depth buffer and to the color buffer as well. If the depth value is greater, we won't write neither to the color buffer or the depth buffer. And this will add the sorting that we want. First, we'll enable depth test. If we run right now, we get nothing. This is because we are not clearing the depth buffer every frame. This is very easy to fix. When clearing the color buffer, we'll also tell OpenGL to clear the depth buffer.
So now if we run, there you go. No more ridiculous ordering problems. Everything is rendered in the proper order. Awesome. I want to show you something. First, let's set the camera to the position of the cube, so that the camera is now inside the cube. I'll also remove the position transformation, so I'm going to remove that. If we run now, you might say, what the hell is this? This is the inside of the cube. You can see the corners, if you look properly, and the colors that are interpolating. So, what is the problem? It's actually not that much of a problem. We're rendering the inside of the cube. However, there's no need to render the inside of the cube if we only want to see the outside. There is a technique called backface culling, which makes sure that only the outside of the cube is rendered. There's also front face culling, which only renders the inside, and that will be good for skyboxes. So let's enable face culling.
This is also very easy. We first need to enable face culling. Next, we'll tell OpenGL to cull back faces. How do we tell OpenGL which side of the triangle is facing the camera and which side is not facing the camera? Actually, it's very simple. If we specify a clockwise direction to our vertices, then the triangle is facing the camera. If we specify an anti-clockwise direction, the triangle is not facing the camera. We can flip this around and make the anti-clockwise direction to face the camera and the clockwise direction to face away from the camera. So how do we specify this? We can do this with the GL front face function. Let's go ahead and implement it.
So in my case, the clockwise direction is the front face. So all we have to do is call GL front face with GL clockwise. And now if we run, we don't see anything. That's good. That means that the inside of the cube is being culled. If we go to our camera and set it back to 5, so 5 steps backwards, there we go, we still get the cube. However, now we're not wasting time rendering the faces inside. Good. And that, my friends, is the end of this video. In the next video, we'll finally be covering the topic of textures. Can't wait. So, yeah. Goodbye, thanks for watching. If you want to be notified when the next video is coming out, please consider subscribing and hitting the notification bell. Goodbye and thanks for watching.